Hey there, folks. Have you ever stopped to think that maybe the most mind-bending question humanity can ask isn't, is there life on other planets? Or, what happens inside a black hole? But rather this, if the universe really was born from nothing, who the heck put that nothing there in the first place? I know. It sounds like one of those questions that make your head hurt, like, what came first, the chicken or the egg? But here we're dealing with something infinitely more profound. We're questioning the very fabric of existence itself. And believe me, by the time we're done here, everything you think you know about reality is going to be turned completely upside down. Today we're going to take a mind-blowing journey through the most cutting-edge theories of modern cosmology. From the Big Bang's hidden secrets to quantum vacuum's impossible physics, from infinite multiverses to cosmic cycles that never end. And here's what's going to blow your mind. Every single answer we find only leads us deeper into the ultimate mystery of why anything exists at all. But before we dive headfirst into this cosmic rabbit hole that's going to change how you see everything, hit that subscribe button, ring the notification bell, and smash that like button if you're ready to have your mind completely blown by the deepest mysteries of existence. Trust me, you're going to want to be here for this journey. Let's go. All right, first things first. We need to completely shatter one of the biggest misconceptions about the universe, and I guarantee this is going to change how you picture the beginning of everything. Hollywood, documentaries, even some science textbooks get this spectacularly wrong. The Big Bang wasn't an explosion in space. It was an explosion of space itself. Let me paint you a picture that's going to make your brain do backflips. Imagine this. 8 billion years ago, there was literally no place for an explosion to happen. No stage, no theater, no cosmic arena. The very concepts of here and there didn't exist yet. Space itself was born in that moment, along with time, matter, energy, everything. Now here's where it gets beautifully human. In 1927, a Belgian priest named Georges Lemaitre, yes, a priest who was also a brilliant physicist, first dared to propose that the universe was expanding. Picture this man of faith using mathematics to peer into the very moment of creation. 2 years later, Edwin Hubble, peering through his telescope at Mount Wilson, confirmed something that should have been impossible. Galaxies aren't just moving away from us. They're being carried away as space itself stretches like a cosmic balloon being inflated. But here's the part that should make you lose sleep tonight. If we rewind this cosmic movie, we arrive at a moment so extreme that our physics simply breaks. We're talking about the first 10 to 43 seconds after the Big Bang, the Planck era, where the universe was essentially running on a cosmic loading screen before the laws of physics as we know them could even boot up. And that loading screen, that's where our journey into the impossible really begins, because what we're about to discover about nothing is going to make the Big Bang look simple by comparison. Hold on to your seats, because what I'm about to tell you is going to completely flip your understanding of reality. When you think of nothing, I mean absolute, complete nothingness, you probably imagine empty space, right? A perfect void where absolutely nothing exists. Well, quantum mechanics just walked into the room and said, "Hold my beer." Because the nothing of physics is actually the most chaotically busy place you could possibly imagine. Picture this. What we call quantum vacuum is like an invisible ocean in the most violent storm you've ever seen, where ghostly particles are constantly erupting into existence and vanishing again in time frames so brief they make a lightning flash look like a lazy Sunday afternoon. We're talking about electrons and positrons, photons, quarks and antiquarks, entire zoos of particles, performing this frenzied dance of creation and annihilation billions of times per second in every cubic inch of empty space. It's like reality itself is constantly having a nervous breakdown at the quantum level. And here's the part that should give you chills. This isn't just theoretical physics mumbo-jumbo. We can actually measure this madness in the lab. It's called the Casimir effect. Put two metal plates incredibly close together in a perfect vacuum, and the quantum chaos in the empty space between them will literally push those plates together with measurable force. Nothing, absolute nothing, is physically shoving matter around. But wait, and this is where your brain is really going to start hurting. Even this impossibly active nothing still requires something to exist first. The quantum laws, the mathematical principles, the very possibility of space and time. So we're right back where we started. If the universe came from this quantum nothing, who or what established the rules that make quantum nothing possible? And that question is about to get even more mind-bending, because some physicists think the entire universe might have literally borrowed itself into existence. Let me show you how that's even possible. Okay, prepare yourself for what might be the most elegant and mind-blowing idea in all of cosmology. Some of the brightest physicists on Earth propose that our entire universe, every star, every planet, every atom in your body, might have emerged from what's essentially the ultimate cosmic loan that never had to be repaid. Here's how this impossible magic trick works. Heisenberg's uncertainty principle, one of the fundamental laws of quantum mechanics, essentially says that nature runs on a cosmic credit system. Energy can be borrowed from the quantum vacuum, but there's a catch. The bigger the loan, the faster it has to be paid back. Borrow a little energy? You can keep it for a relatively long time. Borrow enough energy to create a universe? You'd better pay it back in less than 1043 seconds, or reality's going to come knocking. But here's the cosmic loophole that makes your head spin. What if the total energy of the universe is exactly zero? Picture this. All the positive energy locked up in matter, stars and galaxies is perfectly balanced by the negative energy of gravity pulling everything together. It's like writing a check for $1 trillion, but the bank account it's drawn on also has exactly negative $1 trillion. The net transaction? Zero. The universe might literally be the ultimate free lunch, a cosmic accident that never violated any conservation laws because it never actually borrowed anything at all. Every atom in your body, every thought in your head, every star in the night sky might exist because of the most elegant accounting trick in the history of existence. But even this beautiful explanation crashes into the same wall. Where did the quantum laws come from that allowed this zero-sum miracle? Who wrote the cosmic accounting software that makes this impossible transaction possible? And if you think one universe pulling this trick is hard to believe, wait until you hear what happens when we consider the possibility that this cosmic miracle might be happening infinite times, creating infinite universes, each with their own impossible stories to tell. If you think one universe emerging from quantum nothing is hard to wrap your head around, I need you to sit down for this next part, because we're about to scale up this cosmic impossibility to levels that will make your imagination beg for mercy. Picture this. What if our Big Bang wasn't a unique event, but just one bubble in an infinite pot of cosmic champagne where new universe bubbles are constantly fizzing into existence? This is the inflationary multiverse theory, and it suggests that the same quantum processes that might have created our universe are happening everywhere, all the time, creating an endless cascade of cosmic domains. But here's where it gets personal, and I mean literally personal. In some of these bubble universes, gravity might be stronger, making stars burn out faster. In others, electrons might have different charges, making chemistry impossible. But in an infinite multiverse, there must be universes almost identical to ours, where versions of you are living slightly different lives. There's a universe where you chose a different career, where you said yes instead of no to that life-changing question, where history took a left turn instead of a right. The quantum multiverse takes this even further. According to the many worlds interpretation of quantum mechanics, every quantum measurement, and there are trillions happening in your body right now, splits reality into parallel branches. As I speak these words, countless versions of you in parallel universes are hearing slightly different versions of this explanation. But here's the paradox that brings us back to our central mystery. If infinite universes exist with every possible combination of physical laws and histories, then somewhere in that infinite expanse, there must be universes where beings have discovered how to create universes artificially. And if creating universes is possible, then our own reality might be a simulation running on some unimaginably advanced cosmic computer, which transforms our original question from who put the nothing there to who programmed the reality we think we're living in. The mystery doesn't get solved, it gets infinitely deeper. But what if there's an even more elegant solution? What if our universe isn't the first and won't be the last, but is part of an eternal cosmic cycle that sidesteps the problem of ultimate origins entirely? Roger Penrose, the mathematical physicist who won the Nobel Prize for his work on black holes, proposed one of the most elegant theories about the origin of the universe: conformal cyclic cosmology. According to Penrose, our universe isn't the first, nor will it be the last. He proposes that the cosmos goes through infinite cycles: expansion, aging, heat death, and rebirth. When the universe ages so much that all stars burn out, all black holes evaporate, and only massless particles remain wandering in the void, something extraordinary happens. In this final state, with no mass to define scale, the universe forgets its size. The infinitely large becomes indistinguishable from the infinitesimally small, and conditions become identical to those of the Big Bang. It's as if the universe were a cosmic phoenix, eternally reborn from its own ashes. This theory is beautiful because it avoids the problem of absolute origin. If the cycles are eternal, there never was a first universe. But still, who established the laws that allow these cycles? Who wrote the code for the cosmic phoenix? Now we're entering philosophical territory, but don't worry. Philosophy and physics are twin sisters when it comes to the fundamental questions of existence. Leibniz formulated the principle of sufficient reason. Everything that exists must have a reason for existing, and everything that happens must have a cause. Applying this to the universe, we arrive at the most fundamental question of all: why does something exist instead of nothing? Even if we accept that the universe emerged from quantum fluctuations, or from multiverses, or from eternal cycles, we still need to explain why these possibilities exist. Why are the laws of physics the way they are? Why does mathematics work to describe reality? Why is there a fabric of reality where these things can happen? It's like trying to explain a chess game by describing only the movements of the pieces, without ever questioning who created the rules, who made the board, or why the game exists. Science is extraordinarily good at describing how things work, but when it comes to the fundamental why, it encounters its limits. Let's talk about the most mysterious moment in cosmic history, the first 1043 seconds after the Big Bang, known as the Planck era. To give you an idea of how small this time is, if 1 second were the size of the observable universe, the Planck era would be smaller than a proton. During this period, the 4 fundamental forces, electromagnetism, strong nuclear force, weak nuclear force, and gravity, were unified into a single superforce. The temperature was 1032 degrees Kelvin, and the density of matter was 1096 kb/m3. For comparison, this is like compressing all the mass of the Sun into a space smaller than an atomic nucleus. But here's the problem: our physical theories simply don't work under these extreme conditions. It's like trying to use traffic rules to describe the behavior of subatomic particles. The tools are inadequate for the job. We need a quantum theory of gravity to understand what happened in the Planck era, but this theory doesn't exist yet. It's possible that during this primordial period, concepts like time, space, and causality had no meaning. Maybe the question, what came before the Big Bang, is as meaningless as asking what's north of the North Pole. And now we arrive at the absolute heart of our cosmic mystery, the place where even our most brilliant scientific theories crash into a wall that might be insurmountable. This is what philosophers call the contingency problem. And it's the reason why our original question, who put the nothing there, remains as profound today as it was when humans first looked up at the stars and wondered. Here's the thing that should make your brain ache in the most beautiful way. Every single scientific explanation we've explored today, quantum fluctuations, inflationary multiverses, eternal cosmic cycles, even the most exotic theories at the cutting edge of physics, every single one of them presupposes the prior existence of something. They all require a foundation of physical laws, mathematical principles, logical structures, or at minimum, the possibility that such things can exist. It's like trying to explain how a computer program works by describing its code, its functions, its outputs. You can become an expert on every aspect of the program's behavior, but none of that expertise tells you who created the programming language, who built the computer it runs on. who discovered the mathematical logic that makes computation possible, or why the universe is structured in such a way that information processing is even possible. Science is absolutely magnificent at answering how questions: how stars ignite, how life evolves, how consciousness emerges from neural networks. But when we push toward the ultimate why questions, why these laws rather than others, why mathematics describes reality so perfectly, why there's a stage upon which the cosmic drama can unfold, we find ourselves at the edge of what scientific inquiry can accomplish. Stronger emotional validation of science's limits. And here's what's both humbling and beautiful about this recognition. It's not a failure of science, it's an acknowledgement of science's proper domain. Science studies the contents of reality, not the reason reality has contents at all. It's like using a flashlight to illuminate everything around you, but the flashlight can never illuminate the source of its own light. This recognition of science's natural boundaries has led some of the most brilliant minds in history to wonder, what if the universe bears the signature of an intelligence that transcends the physical laws we study? What if the fine-tuning we observe in cosmic parameters isn't a coincidence but a clue? Now I'm going to present a perspective that divides opinions in the scientific community. The possibility that the universe shows signs of intelligent design. Consider this: the fundamental constants of physics, the strength of gravity, the charge of the electron, the speed of light, seem to be fine-tuned with extraordinary precision to allow the existence of stars, planets, and life. If the strong nuclear force were just 2% weaker, atomic nuclei wouldn't form. If it were 2% stronger, all hydrogen would have turned into helium in the Big Bang, and there would be no water in the universe. This fine-tuning is so precise that some physicists calculate the chances of this happening by chance to be less than 1 in 10 to 120. A number so small it's practically zero. Of course, multiverse defenders argue that if there are infinite universes with all possible combinations of constants, it's inevitable that some would have the right conditions for life. It's like rolling dice infinite times. Eventually you'll get the number you want. But others argue that this fine-tuning might indicate an intelligence behind the creation of the universe. Not necessarily a god in the traditional religious sense, but perhaps a superior intelligence that established the rules of the cosmic game. And now we arrive at what might be the most important insight of our entire cosmic journey, a recognition that's both humbling and profoundly inspiring. Maybe the question, who put the nothing there, doesn't have an answer that our human minds can fully grasp. And maybe that's not a limitation we should mourn, but a mystery we should celebrate. Think about what we are: conscious beings who evolved on a small rocky planet, orbiting an ordinary star in a typical galaxy among hundreds of billions of others. Our brains evolved over millions of years to help us find food, avoid predators, recognize faces, and cooperate in small social groups. The fact that these same brains can contemplate the origin of the universe, discover quantum mechanics, and ponder the nature of existence itself is perhaps the most extraordinary miracle in the known cosmos. We might be like ants trying to understand calculus, or like children trying to comprehend the emotional complexity of adult relationships. There might be aspects of reality, perhaps the most fundamental aspects, that are simply beyond the reach of minds that evolved to survive on an African savanna, no matter how clever we become or how sophisticated our instruments get. But here's the beautiful paradox: recognizing the limits of our understanding doesn't diminish the value of our quest for knowledge. It makes every discovery more precious, every insight more miraculous. Each time we push against the boundaries of the unknown, we don't just learn about the universe, we discover new depths to the mystery itself. Every attempt to answer the question, who put the nothing there, has led us to extraordinary discoveries that have transformed human civilization. The search for cosmic origins gave us quantum mechanics, which led to computers and the internet. It gave us relativity, which powers GPS satellites. It gave us nuclear physics, which powers the stars and might one day power our civilization sustainably. The mystery isn't just the fuel of discovery, it's the source of wonder that makes us human. And perhaps the most profound truth of all is this: you are not separate from this cosmic mystery. You are the universe becoming conscious of itself, matter organizing itself into patterns complex enough to contemplate its own existence. Every thought you think, every question you ask, every moment of wonder you experience is the cosmos awakening to its own magnificent impossibility. And that recognition, that you are both the observer and the observed, both the questioner and part of the ultimate question, might be the closest we can come to touching the deepest truth of existence. So, folks, we've reached the end of our cosmic journey, but actually we're just at the beginning. The question, if the universe was born from nothing, who put that nothing there, continues to be one of the deepest questions humanity can ask. We've seen that the Big Bang wasn't an explosion in space, but of space itself. We discovered that physics nothing is actually a very busy place, full of quantum fluctuations. We explored the possibility of infinite multiverses and eternal cosmic cycles. We discussed the limits of science and the possibility of intelligent design. But maybe the most important lesson is this: the universe is much stranger, more beautiful, and more mysterious than anything we can imagine. And you, as conscious beings capable of contemplating these questions, are an integral part of this cosmic mystery. If this discussion sparked your curiosity about the mysteries of the cosmos, you're going to love our upcoming videos. Next week, we're exploring what would happen if you fell into a black hole, and then, are there infinite types of infinity in the universe? Subscribe to the channel and hit that notification bell so you don't miss any of these cosmic journeys. Leave in the comments which aspect of the universe's origin most sparks your curiosity. You might be inspiring our next video. And remember, every time you look up at the night sky, you're contemplating not just distant stars, but the very question of existence. You are the universe trying to understand itself. Until our next cosmic adventure,